And anyone who was getting CPAM credits that missed it, that issue, or not missed it, but had an issue, that issue has been resolved now. So you will be able to get that sorted out. A handout for this presentation is in the handouts tab on the page you entered this session from. All participants are going to be muted until they are, I need to unmute our, I may need to unmute some, there we go. Some presenters here. And if you have any questions or have any tech issues or access issues, shoot those to me in the chat. You can also throw your questions in the chat. And with that, I am going to turn it over to Brian Shank, and he is going to guide you through this session. So thanks.
Great, thank you. Thank you, Callie. I appreciate your introduction there. And we're going to be going through healthy buildings during and after COVID. Not advancing here, there we go. We're going to have two parts to this session. We're looking at water quality and indoor air quality. So we're going to start off with Steve Elberick. He's going to go through water quality, Legionella risks, some of the testing that can be done, what kind of action and assessments that can be taken to prevent and manage your water systems within your building. After that, I'll be jumping into indoor air quality. We're talking about all the different impacts, what kind of response measures we can look at from varying different perspectives, and what other performance priorities we want to look at within our indoor air quality system. So with that, I'll go ahead and pass it on to Steve to jump into water quality management, or water quality.
All right. Well, thank you, Brian. Thank you, Callie. Appreciate the opportunity to speak with you folks today about what we consider a very important topic. So with that, we'll just kind of jump right in. Just so everyone knows, I'm filling in for a gentleman that was originally scheduled to do this project. He is on site at a facility in Cleveland working on some Legionella response for solid blend. So something that is always happening to us in our lives, in our line of business. We're very passionate about this work, so we do appreciate the opportunity. So initially, I just kind of wanted to go over some high-level information on the bacteria, just in general, and then we'll kind of roll through some different information on why is it prevalent in our buildings and those types of things, and what are some things that we can do to help reduce our risk with this bacteria. So Legionella bacteria, it's just a waterborne pathogen. So what that means is it's a bacteria that can cause people to get ill and potentially die. There's a wide variety of Legionella species. So as you can see, there's over 50 species and over 70 serogroups. And then we'll get into a little bit about the more virulent species that are more susceptible to illness and death, the ones that we want to be a little bit more mindful of. There's actually some Legionella species that aren't associated with human illness at all. So the bacteria leads to Legionnaires disease, which I'm sure you've all heard of, or Pontiac fever. Pontiac fever typically doesn't lead to death. It's more just an illness. Legionnaires disease doesn't always lead to death if it is caught early, diagnosed, and treated properly. Legionnaires disease is going to present itself very similar to pneumonia. So, we encourage all the folks that we work with as clients and vendors and partners to, if you've got a team member that works around commercial water systems, cooling towers, and they get diagnosed with pneumonia, to always ask their doctor to do a Legionnaires disease test just to validate that they don't have that. It does get misdiagnosed quite often. And the tricky part is you don't treat Legionnaires disease with the same antibiotics as you would pneumonia. So sometimes if someone thinks they have pneumonia and they're not getting well and they're taking the antibiotics, they're not getting well because they actually might have Legionnaires disease and it's not being treated properly. Legionnaires disease is located in all water systems. It can be found at really low levels in rivers, creeks, lakes, and then typically it'll be found in more concentrated or higher levels in commercial buildings, cooling towers, and those types of systems due to, well, some of the things that we'll talk about today, due to the design and operation of those systems. And it's contracted by aspirating or inhaling a water droplet that contains the bacteria. Sounds like it would be kind of challenging to do that, but if you think about taking a drink of water, getting a little bit in your windpipe and you cough, it's actually as simple as that. So you can get it into your lungs pretty easily. So, yep, thank you, Brian. So Legionella is not ubiquitous, and I think that this is a pretty important slide. What that means is it's not literally in every water system. The only way to know if it's in your water system is by validating with Legionella samples. But just some statistics on some facts that are out there on the different percentages of water systems that are affected by the bacteria. As you can see, one of the most at-risk types of facilities is going to be your hospitals and assisted living facilities, mainly because of the population type in those buildings. You've got elderly folks, at-risk folks getting surgery and immunocompromised procedures. So it varies quite a bit, 12 to 70%. You can see if you've got cooling towers, that 30 to 50% of cooling towers have the bacteria. That can be easily rectified by following a water treatment program that coincides with ASHRAE's recommendations, cleaning your tower, having the proper biocides in place, and being fed properly. So in general, again, it's not found everywhere, but it's found in about 50% of building water systems and commercial cooling towers. So I had mentioned the different species and serogroups. So this one is called Legionella pneumophila, serogroup 1. There are several serogroups of pneumophila. Serogroup 1 is it's the deadliest. It's associated with the most human illnesses and deaths. I believe the statistic is around 93% of acquired illness and or death from Legionnaires disease comes from specifically pneumophila serogroup 1. Serogroups 4 through 6 are associated with another couple percentage points of that. But as you can see, there's only a few that really impact human illness. And so it's key that if you decide to do testing, that you can kind of understand what you're looking at. Just because you have Legionella in your water system doesn't mean it's the type that could make somebody sick. And it doesn't necessarily mean that it needs to be disinfected or remediated. So as you can see, that last sentence, CDC is attributing less than 5% of the non-pathogenic species to human illness. So again, Legionella pneumophila is kind of the poster child, if you will, for infection and human illness. Okay, so talking about a little bit about why our systems in commercial buildings like schools, hospitals, commercial office buildings, etc., are very susceptible to allowing the bacteria to colonize and grow to unsafe levels. And I just want to be clear on that. When I say unsafe levels, there's no scientific information out there that says that if you have a small amount of Legionella in your sink or a large amount, that it is more likely to get someone sick or not. So what I mean by that is when you test for Legionella, you're gonna get a report that's gonna say you've got 1 or 10 or 100 or 1,000 colony forming units of bacteria. And what that is the quantity of bacteria in that particular location that you tested. It's not been proven, and there's no scientific data to support that if you have 1,000 CFU or 1 CFU, that it's more or less dangerous. What has been proven by science is it's based on the percentage of positive sites tested. So when we test buildings, we're going to go through and we're going to pull a sample set of 10 or more samples to get a representative set of the distribution. And with that, what we like to look at is how many of those samples are positive. So if I pull 10 and I've got 50% positive, my building is going to be at higher risk for someone to get sick because I'm going to see the bacteria throughout the building in multiple locations. So I just wanted to provide some clarity on that. But the reason buildings are designed to grow Legionella, as you can see, we've got high surface area to volume. So if you think of a domestic plumbing system, you've got miles of pipe in these buildings. And a lot of times you've got low water flow or low water usage. You can have sediment and corrosion and biofilm accumulation in your piping system, which is all normal for commercial buildings, schools, to have those things. And when you look at a pipe from the outside, a nice shiny copper pipe looks clean, looks new. On the inside, it's going to look a lot different. So you're going to have that corrosion, you're going to have the biofilm buildup, and that provides food sources and places for that bacteria to hide and grow and multiply throughout the distribution. The other thing, and typically when we find the bacteria, it's going to be predominantly in the domestic or potable hot water system versus the cold, and that's due to temperature. I've got another slide that'll show you some temperatures that are great for the bacteria to grow, that are great for the bacteria to be killed at, and those types of things. So, but due to scald protection, we're not allowed to deliver water above 120 degrees Fahrenheit out of the fixture due to scald protection regulations in the state of Ohio. And when you maintain it below 120, let's say 110 to 120, that's actually a great temperature for the bacteria to continue to grow and reproduce. So some of the things that we have in place for protection of other items like scald and burn allow this bacteria the opportunity to thrive. Cooling towers, same thing. Most HVAC cooling towers are going to be operating around 90 to 100 degrees Fahrenheit, which is an ideal temperature for that bacteria. Decorative water features, spas, those types of things as well. So temperature plays a big role in this bacteria, and that's one of the issues with building design. All right, perfect. So just below, you can see that we've got a table here that spells out ideal temps and not so ideal temperatures for the bacteria to thrive or be killed or go dormant. So as you can see, when you get above 158 degrees Fahrenheit, you can actually start to kill it. Well, in fact, you can kill it at 140 or above, but you get a much quicker kill at the higher temperatures of 158 to 160. So just some food for thought. As you can see, though, Legionella growth range ideal is 95 to 115. Typically, your incoming cold water is going to be 65 to 70 degrees from the city. We're going to, put that into our domestic hot water system, and we're going to get that temperature up to 120 coming out of the fixtures. So we're really in that ideal range. If you notice, though, at above 122, Legionella can survive, but does not tend to multiply as well or thrive and reproduce. So what we like to work with our clients and partners on is you can maintain your hot water tanks and temperatures in those tanks above 122 and still use mixing valves and other engineering devices to meet your scald requirements at the fixture. So what that does is it allows us to get, a good kill rate in the tank or the source where the hot water is going to come from, and not allow bacteria to grow inside that primary source that we're delivering hot water from. And that is one of the biggest things that we look at initially is where are your hot water tanks being maintained? We've seen them down in the hundreds. So keeping an eye on those things is really critical and part of the management process that we'll talk about here in a couple of slides. So again, another slide with a few more fun facts on why buildings are so prone. As you can see with a couple of the pictures that we provided, how complex some of the fixtures are today. There's a lot of different parts and pieces that can get dirty or contaminated or allow a piece of bacteria to land on and stay localized in that spot and continue to grow. So being mindful of the types of fixtures that you're putting in, how they're being used. Increased water age is something that we talk about a lot. And what that means is the water is spending more time in your building, in your piping systems, versus coming straight through the building from the city, all the way out the fixture and back down the drain. So with green technologies, we have lower water usage. With non-touch fixtures, we have lower water usage. We have more complicated aerators inside of those fixtures. And there's been a reduction in hand washing with disinfectant gels and the alcohol wipes that people use. And we have the hand stations, which are great for sanitization and other things. But what that ultimately does is it reduces the water load on your building and allows that water to sit more stagnant in your piping, which increases temperature, drives off disinfectant residuals, and allows the bacteria to grow. And you can see that in that second bullet point, we talk about disinfection residuals. So the city is required to deliver 0.4 ppm of free chlorine all the way up to 4 ppm of free chlorine to basically to your meter. And then once it enters your building, it's no longer their responsibility. So at those lower residuals, if you're only getting a 0.4 to your meter, the likelihood of you having good chlorine throughout your facility is very low. And especially when you get into the warm water systems. When you get into warm water, that water is typically going to be a recirculating loop. As that water is circulating throughout the building, the heat is literally driving the chlorine out of the water. So again, you've got the warm temp that's perfect, and you've got no disinfectant in the system. So what we like to talk about, and what I'll get into briefly, is part of the water management plan is having flushing protocols in place. And what that allows you to do is reduce your water age. That way you can maintain better temperatures and better disinfectant residuals. So again, just a couple of fun facts here that we've kind of already touched on. Water age due to unused or underutilized fixtures. These are some of the key indicators that you may have an issue or Legionella growth can increase. So low flow, low temperature, and low disinfectant. So talking about testing, we have a lot of folks, and I think the awareness level has come up quite a bit with COVID and some of the other things that we've experienced in 2020, and just having conversations like this. Years back, we talked to a lot of folks that they wouldn't test. We're not required to test. If I don't know it's in my building, I don't need to do anything about it. And so I think with the heightened sense of awareness that there's more testing going on, and just a couple of reasons why we want to test. And I've touched on some of this already. Are you in the 50% of the buildings that have it or don't? So you could test, and we test a lot of buildings that don't have the bacteria at all. And they basically wait a year or 6 months and they test again. Like I had mentioned before, not all Legionella have the same risk. So we could find Legionella that's not an issue for human consumption or human ingestion. Again, we wouldn't have to do anything, but we would have that data to make an educated decision with. And then again, what level is present as far as percentage of distal outlets positive, because the more you have as a percentage, the greater that risk is going to increase. And that's how we tend to manage. But those are some of the reasons that you would want to consider testing. Again, some strategies here. And I had talked about flushing a little bit. So what do we do if we find the bacteria in our systems? There's a couple things we can do. Almost immediately, we would have you start flushing the system. And what that's going to do is it's going to pull that aged water through the piping. We're going to get fresh water in from the city. We're going to utilize the chlorine that they're providing us to pull it through the system quicker and help us try and knock the bacteria down. Typically, that's not going to be, if it's already in your system, a flushing plan typically will not remediate it completely. It will help reduce it. What we like to do with flushing plans is have those as ongoing plans as a preventative maintenance measure once we have the system under control. Some of the other things that we typically do, the two primary is we can do a monochloramine system that is temporarily installed. In the state of Ohio, you can operate that system for less than 60 days per the Ohio EPA without being considered a public water supplier. And then the other one is a hyperchlorination. The hyperchlorination, what we do is we come in and we're going to inject a very strong percentage of bleach into the incoming water main. And we're going to pull that through the entire system. We're going to verify that we've got the disinfectant at every single fixture in the building. We're going to log that. We're going to soak it for a period of time. And then we're going to flush that system all the way back down to regular city water levels, verify that. And then we wait about 48 hours and we do a retest to verify that it was effective. For problematic systems that have ongoing Legionella positive results, there are some long-term options that you can put in place. Supplemental chlorination, chlorine dioxide, copper, silver, and monochloramine. We typically go with the monochloramine. It's been very effective long-term and short-term for Legionella control. It's also going to have less of a corrosive effect on your plumbing system. As you can see, it mentions over 60 days PWS. And what that means in the state of Ohio, if you put one of these systems in place permanently on your facility due to bacteria issues to control it, you now have to become a public water system through the Ohio EPA. It's a fairly simple process, but there are some, as far as getting the permit, but there's going to be some requirements that you have to follow to meet the Ohio EPA's suggested guidelines for maintaining that system to where we're not making anybody sick from the disinfectant that we're putting in. So again, we've got some great solutions and technologies available to us today to take care of this bacteria when we find it in systems. So we're going to talk a little bit about prevention. Brian, you can just jump right to the next slide. What we typically do when we get engaged with a facility and things that you can do on your own is we like to go through and conduct a risk assessment. The CDC has a environmental assessment tool available on their website specifically for Legionella. That is the same document that we use. We've worked with the Ohio Department of Health a lot to make sure that we're collecting all the information necessary on the sheet, as well as any additional information that may be needed to fully understand the risks inside of your facility specifically. So there's not going to be a one size fits all approach. Every building is going to be different. The temperatures, the chlorine residuals, the piping distribution. And so we may have different approaches for different types of facilities. Even if it's, a high school, Centerville High School, or, let's say Ansonia, it doesn't really matter because those buildings are going to be designed completely different. They're going to have different engineering devices and mechanical devices that we'll need to identify and see what the risks are. Part of that risk assessment too, you can also consider there are other opportunistic waterborne pathogens other than Legionella that we should be mindful of as well that can be found in our systems and that can cause human illness. Some of those are listed at the bottom of the slide. You can go ahead, Brian. Thank you. So basically, after the assessment, what we suggest is to implement a water management program. ASHRAE has guidelines out there and standards that can help you to develop a plan. CDC has a really good toolkit that you can walk through to put together your own plan. It's also a service that, you know, companies like Solid Blend offer. And basically what you're going to do is you're going to look at a lot of these things that we've been discussing, and you're going to discuss ways with your team on how do we want to manage these things? How do we want to collect data? What do we want to do with the data? Are we doing inspections on certain pieces of equipment on a regular basis to make sure that we're staying in compliance of the parameters that we've set? So an example would be hot water tank. We said we wanted it to operate at 125. That's what it was designed to operate at, but nobody's looked at it in 8 months and it's only operating at 105. So having checks and balances in place is really key. Some key elements of the water management plan. Team. So this slide is all about the types of folks that you would want to have on your team to help make decisions on how to manage your water systems. So infection control is a role that you're really only going to find in hospitals. We're not going to see that inside of your organizations. But your facility manager, anybody in the engineering department, we'd like to have administration on that way. We've got the folks that have the financial decision-making capability on the team as well. Facility manager, maintenance, engineers, the guys that know the systems and know the equipment. And then your water treatment provider, if you're working with somebody for cooling tower treatment, or those types of things. And then Legionella experts, either a Legionella CDC certified lab, a Legionella consultant that can come in and help you guys understand how to do the testing, where to pull the samples, what do we do with the information when we get it, those types of things. Those types of folks should be on your team to help guide the plan and the decision-making process. So high-level view elements that you're going to see in a plan. You're going to want to identify the team and define responsibilities and roles. We're typically going to have a high-level water system or flow diagram of all of the potable and non-potable systems in the building. We're going to have water system analysis and control measures, and that's going to be your temperatures, chlorine residuals, what parameters do we want those to be at, how do we maintain them. That can also be part of your flushing protocol. So monitoring and corrective actions. This is where you're actually going to go out and implement the plan, monitor your levels, adjust temperatures as needed, flush fixtures. And then the verification is basically confirming that everything that we're doing is working. And again, in our opinion, the most effective way to do that is to actually test to see if what we're doing is working. And then you're going to document. So you're going to save your reports. You're going to keep your log sheets on file, either in your software program or your PM program, or you're going to have hard copies. And we're going to look at those as a team, and we're going to update those on a quarterly basis to make sure that we're being compliant. So again, this is just a table of contents sample from a water management plan. It's got a lot of the different types of components that we would suggest that you have. System specifics, we've got resources, we've got information on contingency response plans. You know, how are we going to respond to temperatures out of range or positive bacteria samples? How are we maintaining our systems? So those types of things. And we just wanted to provide a sample for you guys to kind of see as well. So when we get into implementation, and I touched on this already, basically what we suggest is to perform Legionella analysis, start there, and let's see what we've got in the system. And if we find it, it doesn't have to be panic mode. We don't have to get a bunch of people involved. You don't have to notify the state. The state will get involved when a human gets sick. Okay, and I think that that's important for folks to know. If you test your building and you have positive results in your building, you are not required to notify the state of Ohio or the health department. You are only required to notify when someone gets sick. So once we do the analysis, we do system monitoring as well, which is your temperature and chlorine residuals. The flushing protocol comes into play here. And what we suggest, and it may seem excessive because we may not be doing this now, is we suggest that you flush every fixture in the building at least once a week. So if you've got fixtures that are being used on a regular basis, you don't need to flush those. But if we've got science labs that have been closed because of COVID and the kids aren't coming to school, and there's 15 fixtures in those classrooms, we need to make sure that we're running water through those fixtures on a weekly basis. That ensures good chlorine residual, good water temperature, good flow. Yeah, so last slide, and I didn't want to take up too much time. Sorry if I did, Brian. Last slide is just some good resources for you guys. Ohio Department of Health and EPA recommendations for unoccupied or partially occupied buildings and flushing, ANSI and ASHRAE content, and then the CDC toolkit website link down there at the bottom as well. And I think with that, I've come to the end of my slides, Brian. And we're going to hand it back over to Brian, and he's going to get into his indoor air quality. Again, I know I imparted a lot of information, but I appreciate your time, and we'll hopefully get some questions answered before and or after.
Great, thank you, Steve. Appreciate that. Jump right into this indoor air quality stuff, and I always like to start with this slide because it kind of tells a lot of the story about what we're dealing with right now, but also how indoor air quality affects us on the regular basis. So we spend a lot of time indoors. We consume a lot of air when we're in buildings, and we're thinking about our health. We don't often think about the air we breathe. We think about the food we take in, or the amount of exercise we're getting, or the beverages that we're drinking throughout the day. So you know, in addition to that, when we're indoors, all that time of our days, we're breathing in air that's 10 times more contaminated than the outdoor air. So, and that's mostly due to, you know, sometimes our systems within the building, but also the amount of fresh air that we're getting throughout the day that it's just kind of containing within the buildings at all times. A couple other points here. You know, indoor air quality is one of the top 5 most urgent environments to public health. So that's something to think about in the scheme of things, and how that value provides from what the air we're breathing does to us, right? When it comes to school districts and school buildings, you know, 24 million Americans have asthma, and that's the #1 cause of absenteeism in schools. So what can we do to look at the indoor air quality of our schools, and how that affects our student population and our staff population for that matter? You know, another one of the key critical points to school district indoor air quality is children. You know, our children are breathing more rapidly than adults because their lungs are developing. They're at that stage where they're developing at the most critical points. And those pollutants and pathogens and things like that are actually reside in the lower breathing zones for those young children. So inherently, they're absorbing more pollutants and pathogens that are in our air. So just something to think about when we're looking at the value of indoor air quality in our buildings. In addition to that, you know, health has kind of got a different definition than it used to in years past, or in decades past, I should say. You know, for a long time, health was just not being sick, and you know, as Americans and people just around the world these days, we're more proactive about our health and how our physical health is impacted by our mental health and our social well-being as well. Just to dive into a little of the COVID piece to this, you know, one of the actions you want to look at is what the business impact versus the effectiveness is. And this chart on the left-hand side is actually from a book that came out oddly timed in January earlier this year, but it actually charts, the value of those different things. And if you look at the bottom, we're looking at work from home policies and remote learning type components that are the best way to stay away from those pathogens was to just keep people away from each other. And then next up from that was, how do we bring in the people that really need to be there? So bringing back the teachers, but keeping the students on remote learning. And then next is going to include a lot of the things we're going to talk about today, which is the engineering controls. So what can we do with our buildings that operates them a little differently, that improves the indoor air quality within the facility? And above that, we have the administrative controls, which are, how do we de-densify workplaces and actually keep people social distancing at our workstations? And how do we just relocate and have some wayfinding for people to get around each other and social distance in that manner? So, and then above that is the PPE, which is, it's on that low business impact piece because they're so cheap, very, very cost effective to wear masks. And that's why it's one of the most simple things that we can do right now for the pandemic to help each other's health and our own health. Also wanted to point out some of these resources that are available from Responsible Restart Ohio. We're all planning for recovery right now, and I think we probably have all been planning for recovery for 12 months, it seems, right? But we're really starting to get towards that point where we are doing that. We already talked kind of about the physical environment changes of office layouts and how we might look at indoor air quality differently than we did before. We've certainly done the cleaning and disinfecting, but how has the pandemic changed the way we look at things? And from my experience, I've kind of been in this healthy buildings space, per se, for the last 4 or 5 years. And, this is certainly expediting the movement towards healthy buildings and how we look at indoor air quality, not only how it affects us, but how indoor air quality affects our goals when it comes to energy and comfort within the buildings. It's also having us look at accelerate sustainability and resilience planning. So what are we doing now that impacts what we do later? And obviously we want to learn from this pandemic and have things in place that we can quickly jump back into if something else comes up that we need to do that as well. Like I said, the resources from Responsible Restart Ohio are very valuable too. So be sure to look at those on the state websites. So now we're kind of going to get into the big meat of our presentation. We're going to be looking at 4 main critical pieces to what we consider healthy buildings from a mechanical perspective and from an air quality perspective. So ventilation performance, purification strategies, filtration replacement, what that might look like, and then disinfection protocols. And we talked about that in a couple of different ways, but there's disinfection of your actual systems. There's disinfection at the surface level. And we want to look at all those aspects of how that affects the air quality around us. So ventilation performance, when it comes to medical professionals right now, they say bring in as much outdoor air as you can. But it's very critical there that is filtered outdoor air. So where that is the last resort, we want to open windows, but we always want that to be the last resort because we want to not affect how that air is coming in and affect the other components of our building, which is energy performance and the comfort of our facilities. So if we were to open the windows, we might bring in more outdoor air, but we also might bring in a lot more pollutants from outdoor, from a crop field that might be next door or a construction site that might be next door. And that could be bad in other ways. So we want to make sure we bring in filtered outdoor air through our mechanical systems wherever possible. And that intent is to dilute the indoor air with fresh outdoor air, and that is actually have a cleaning process to it as well. So important to verify the operation of your building pressurization. So if you have any rooms that you open or shut a door and it opens and shuts another door, or vice versa, you shut one and then it starts to impact, that there's a building pressurization relationship that we want to look at. Understanding air changes within a facility. So air changes is just a calculation of how much air is circulating in a room based on its square footage and really its volume, so it's square footage and height. And make sure so many air changes are happening an hour. On the regular, you want to get 3 air changes. During a pandemic, you want to have 6. So we want to double that requirement on the regular. So 3 is good, 4 and 5 is better, but 6 is best right now when it comes to the environment that we have right now. So automated controls. So what can you do with the control systems that you have for your facilities? Can you vary outdoor air that's coming in? Can you increase the outdoor air that's coming into your facility in a controlled manner, like I said, through filtered situations? And then also how that is related to the exhaust systems and ventilation systems that are in your building and the damp.
It looks like Brian's reconnecting his audio, so we'll just hold on here a second while he's connecting. Technology is always a fun thing. So there we go. I think he's back in.
Yeah, sorry about that. I'm here. Can you guys hear me okay, Callie?
Yep, now you're good.
Okay.
Awesome.
Sorry about that. My phone is working, so I'm not sure what happened there. Just closed. So apology for that. Technology is wonderful sometimes. So back to ventilation performance here. So the space conditions are what we want to look at, and what space conditions are critical components of our indoor air quality. So we're always looking at temperature and humidity. Those have a very direct relationship between each other, but carbon dioxide is a good, it's a good way to look at what our ventilation performance looks like. So we all emit carbon dioxide, so it tells us what our occupancy looks like in a building as well. And right now during a pandemic, you want to limit room transfer air, because if we have a space that could be contaminated, we don't want that to transfer into another area where we could contaminate more people when it comes to something like this when a pandemic's going on. Considerations to look at is energy cost impact. So, when we bring in more outdoor air into the facility and it's really hot outside, we have to cool that air. If it's really humid, we have to dehumidify if we have the ability to do that within our system. And just like I said, system capabilities are important. You want to know if you have the ability to do that. You want to know if you have the ability to vary the outdoor air coming into your system, in your building, if your systems are capable of doing that. And ASHRAE standards that we look at, I know we talked about ASHRAE standards on the Legionella side, and this is very relevant on the indoor air quality side too, is ASHRAE 62.1. That is the standard that our buildings are built to for ventilation. And ASHRAE 55 is the standard that is built for comfort, which is our thermal comfort and how we feel based on our activity level and the things that we're wearing. Energy impact, so like I said, we want to look at that energy impact, but how do we evaluate the systems we have? What kind of monitoring of those systems can you do? So when you do bring in outdoor air, can you monitor that to see if it is having an energy impact? And then strategically using those demand-based system controls. So demand-based ventilation is something that's very often used in our facilities. If we have the ability to evaluate CO2 based on a space, where we're bringing in more ventilation air, the more occupied that facility is. With the pandemic, a lot of those have been disabled, and we're starting to just bring in as much outdoor air as we can. And that's very much an energy thing, right? We've done that, and those systems are in place to not overconsume energy by bringing in more outdoor air and having to heat or cool that. So you want to just kind of use that more strategically now, and realistically, you want to not use it at all right now because of the pandemic. But where we're starting to get back into things, we can start to look at reevaluating what that might look like. So purification strategy. So these are ways that we clean our air, right? So how can we clean the air that is within our systems in a way that is centralized and effective? But what other units or other systems are available to do that even at the room level? So we're going to go through all the different technologies that are available and things that you can use to do that. So UVC, so ultraviolet light, is light that is being applied within mechanical equipment. So the real intent of this is to clean the coils or clean the equipment when it's put into a mechanical side air handler or a heat pump or something like that. Inherently, it does start to do some air cleaning, right? So it's killing viruses and bacteria and germs that are growing on those coils. It's keeping those from our air systems, which is good. But that makes that is a passive air purification strategy. So when it comes to pathogens in our air, like this virus or any other viruses like a flu, those would have to actually come in contact with this light within that mechanical equipment to be killed or neutralized. But it does clean and treat that airside equipment and inherently do some air cleaning in the process. So considerations, there are some safety measures that need to be in place if you were to install a UVC technology within your mechanical equipment. Mostly because this light is volatile to us. We've actually had some technicians that have been in the field that they didn't know that there was UV equipment and within there, and we'd have opened the door, and it's really harmful to our sight and to our eyes for short term, even if only exposed to it very quickly. So having switches and stickers that notify people that are working on that equipment is very important to make sure we protect those people. Because it's volatile, it's going to break down plastics and wiring and media in the locations where it is. So it's something to think about. And also the bulb replacement. These have a lifetime that's about 9,000 to 18,000 hours. So you're looking at replacing these about once every 1 or 2 years. And that cost could get really high really quickly. So you want to look at that maintenance aspect as well. Other technologies that are out there are needlepoint bipolar ionization. That is a specific type of ionization that's out there. So, if you were to search ionization right now, you'd find a lot of different forms of it. And particularly at the building level, we prefer to use the needlepoint bipolar technology because it doesn't create any other harmful issues within our space. Number one of those being ozone. You don't want to put anything in your systems that's creating ozone. There are systems that are specifically meant to create ozone. And while it's good in certain capacities, it's not good at a large level. So our preference is to install things that produce zero ozone. And there are certifications to look for to make sure that products are not installing with producing ozone, I should say. What needlepoint bipolar does, it's completely electronic, so it's actually providing positively and negatively charged ions into the air at the molecular level. So you're actually providing those ions in the air that then get attracted to opposite polarities, and then those two compounds agglomerate. So they're attracted to each other, they connect, they strip of the harm of the products that they need to survive. So oxygen, hydrogen are kind of the byproducts there. And then they also become larger because they're attracted to each other, and then they can be filtered out through our air systems and our typical filtration systems that are in our mechanical equipment. Because these ions actually go into the space and through the ductwork and then actually clean outside of the mechanical equipment, that makes them an active air purification stream. In addition, they also break down odors within facilities and volatile organic compounds. So we see a lot of furniture and paints and things like that that actually emit VOCs in varying different forms, and these will actually break them down and activate them just as much as they will other pathogens and bacteria and germs in the air. So considerations, it's kind of talked about those non-harmful byproducts. UL listing is those certifications that I was talking about when it comes to no ozone. So you want to look for 867 and 2998. And there's a variety of different applications for different types of systems, right? This first one is a smaller device. It's actually the back end of the top one on this slide. And then the one below it is very similar, but it's actually used in a different manner. So the top one would be put into a ductwork right after a unit, and the bottom one could actually be installed directly into a mechanical device, mechanical equipment. And they're very low maintenance. So that's another side to this, is that these actually, for the life of the product, have nearly no maintenance and because they're self-cleaning and there's really no components that break down. The carbon brushes are expected to last about 20 years, which should exceed the life of the equipment, which lasts about 10 to 15 years. Some of the other purification technologies that we'll talk about here, these are products that are proprietary in nature, so more often than not, they have some form of both UV and ionization built into them, but they're a packaged device. They are proprietary in that only one person may make those, or they have varying types of it. But they're definitely, you know, valuable in different circumstances, right? There might be applications that are very specific that these types of products would work well in. And there's a couple different types of technology to look at. They are also an active air purification strategy, just like regular ionization, because they do have a form of ionization. And the byproducts of these are what they call friendly oxidizers, which are the byproducts are good things for our environment, like oxygen, hydrogen. So stuff to think about as well. Considerations are very similar to ionization. You're going to get better performance out of your equipment. They're UL listed as well. Low maintenance, and the installation can be very quick. These do have a cell replacement because that's how they operate for the UV and the ionization built in. Is typically they have some form of a cell, and they will need to be replaced every 3 to 5 years. So something to think about when you're thinking about the long-term costs of them as well. Purification strategy, what's the energy impact? So compare the total costs. We talked about several different things here. I hope I'm not going through them too quickly, but UVC does a certain type of work. So it's a passive air cleaning technology and has a certain maintenance related to that. Ionization, as well as the proprietary products that do both, have an initial cost and have little or low maintenance costs when it comes to what needs to replace over the long term. And what's the additional benefits? Is it going to do anything else for your building past the pandemic or past cleaning in the air that's going to provide more of a value to the building as well? How does it impact the ventilation performance? You know, products like ionization are going to make your filtration perform better. It's going to improve your filtration performance. I'll talk about that a little bit when I get there. But ventilation performance now, but also what's the ventilation performance look like for the long term? Products like ionization will actually allow you to, because you're cleaning the air, you can utilize some of the strategies within ACTRACE standard 62.1 to reduce the amount of outdoor you bring in because you're cleaning the air within. Certainly something we don't want to do right now during the pandemic. We want to bring in more outdoor or as much as we can as possible. But after the fact, you can use these to do other things that actually improve your energy performance in the building as well. So something to think about when you're evaluating whether that's the right path for you. So filtration replacement, you know, where everybody has filters within our mechanical equipment, and we may be doing some filtration within our rooms, right, with standalone units. But something to think about, you know, I talked about the medical profession and, you know, what guidance may have come from that right now. Because of the pandemic, a lot of times it was to increase your filtration, whether that was increase your MERV rating, which is what filters are rated on. Most standard filters are like an 8, which is on the low end. And the larger size you go to on a MERV filter is actually what the smaller the particulate that actually filters out. So, and once you get past the MERV rating, which the highest it goes to is 16, you get to different types of filters like HEPA and carbon and charcoal, which actually get down to even smaller particulates. So the concern we have there is you know, your air handling equipment specifically would have been designed for the MERV ratings filters that are in them, and they actually probably won't perform very, very well with HEPA filters in there, or they would require additional maintenance. So something that needs to be evaluated on a deeper level, certainly, to make sure that that's the right decision to do within the mechanical equipment. So certainly you want to partner with your local mechanical contractors to look at that and actually understand what that might do to the other maintenance aspects of your mechanical systems, or even to understand if your systems might be more capable or have enough speed and things like that in the fans to be able to perform and work through a more restrictive filter. Because the biggest thing you don't want to do is restrict airflow on the back end. We talked about air changes earlier, and just as much as filtering out the air is important, the amount of airflow that comes in and leaves the space is important as well right now during a pandemic, but also during any regular time as well. So system compatibility, I kind of talked about that a little bit. What's the system pressure drop? So what does that create? What does that do within our systems that might create other changes to our mechanical equipment? Coordinating with your mechanical contractors, and what's the increased maintenance costs and lead time. So if you want to upgrade to a MERV filter, is there a longer lead time to get that filter in? And what cost that recurs if you're changing your filters already 3 and 4 times a year to increase the MERV filter and the additional cost that might have. Mechanical system cleaning. So this is the disinfection piece. So you want to make sure there's protocols in place to clean our systems. A lot of our preventative maintenance plans include cleaning our coils on the outside, but not cleaning the coils on the inside, which is where some of the bacteria, mold, and mildew could grow. And I'm going to show that on the coil here on the left-hand side. That's when you start to have, other pathogens and other that are not good for our air quality that might grow. So you want to look at cleaning your coils, cleaning your drain pans, cleaning the cabinet equipment, and your fan wheels. And the dust is building up on those, just like it builds up on the fans in our homes. It can build up on the fan wheels within our mechanical equipment now, which is the main form of moving air within our mechanical system. So it's very important to look at that in cleaning protocol as well. Us locally, we partner with some local companies that do surface disinfection, similar to the microbial or the 360 devices that are electrostatically charged to apply chemical cleaners. These disinfection pieces are going to actually look at mechanical cleaners, so they're actually applied electrostatically as well, but they actually are putting a layer on the surface that is actually breaking the cell wall. So it's actually small spikes that are actually put on the surface. They're breaking the cell wall of any germs and pathogens that might land. So what you're doing there is you're doing something that should be done in conjunction with chemical cleaners, just like they are, just like you're typically doing, cleaning counters, cleaning handles, cleaning touch points. But this is actually providing a mechanical cleaning service to there, and it's cutting down the amount of germs that are building up on any type of surface between those chemical cleanings at the surface level. So something to think about. These are EPA registered disinfectants as well. So it's very important to use in those types of products that are approved by the EPA as well. So what are the performance priorities? We kind of went through a lot of things here. You want to understand how healthy building protocols and ventilation performance and things like that directly relate to the comfort of your occupants within the building and the energy efficiency goals of the building as well. So I want to create some performance indicators within each of those three and how they might impact each other, because it might change the decisions that you make on the ventilation side or the purification side, because you want to balance all three of those things within your facility to kind of have a good holistic approach to everything. And then proactive strategies versus reactive strategies. It's always better to be out ahead of things within our facilities when it comes to indoor air quality than to try to come back and fix a problem that's already in place. So initiating an IAQ management plan is one of the best ways to do that, is to be out ahead of things. So making sure maintenance is happening, preventative maintenance, and having preventative maintenance for your indoor air quality is very important as well. So all things to think about when we're looking at what the priorities should be right now, but also really for the long haul, because indoor air quality, is going to stay and be a very important factor in our buildings way past the pandemic as well. Also wanted to throw out some of these new normal terms, right? We're hearing a lot of new things, but we also know that our occupants within our facilities are learning these terms from different things. Air changes per hour might be referred to air exchanges in different environments, but in our environment we call them air changes per hour, and that's something that a lot of our everyday occupants understand now. Ionization, MERV. A lot of folks outside the mechanical world didn't really understand what a MERV rating was. Hopefully you do now after the presentation today, but you may have heard about it in the news and things like that because of the pandemic. So things we want to be understanding of and have a good eye to right now, because they're going to be out and in our world even past this pandemic, like I said. So that kind of comes to the end here. I don't know if anybody has any questions for us, for Steve or myself, whether it's water or indoor air quality related. We're certainly happy to answer any of those questions.
All right. Well, thank you very much, Brian. And we are right at the end of time. So I don't see any questions in chat. Give it another couple of seconds here. And just a couple of housekeeping notes. Again, remember to take your survey so you get your contact hours. We'll have about a 15-minute break, and then we will have our advocacy lunch and learn session on the Fair School funding plan. So make sure to join us with that. And after that will be dedicated trade show time. So you could visit, I think you could probably visit Brian at Weigel's exhibit booth, or some other folks, some of his colleagues. And I'm also seeing a note from Christy Fielding there in the chat that don't forget ESSER funds can be used for these types of improvements.
Oh, certainly.
And lastly, just make sure you you participate in the Scholarships for Students contest by visiting the expo booths and filling out the little surveys there, and then join us for the concert tonight. So I hope you all enjoyed. And thank you very much to all the speakers, and we will see you all soon. Thank you.
Thanks.
Thank you. Have a great day.